Hello everyone. Today I'm very excited to share a brief overview of our research. It is about examining the algorithmic fairness in predicting high school dropouts. Our study was accepted by the Educational Data Mining Conference 2024. I'm Chenguang, and Zhang is my collaborator. We are both PhD students from the Teachers College, Columbia University. This is the overview of this brief presentation. I will walk through the introduction, talk about the background of our research, and the data and the variables such as the outcome, the predictors, the oversampling strategy we used. I will also talk about the evaluation on the predicting performance, also the examining the algorithmic fairness on the selected models. And finally, I will summarize our main conclusion of this study. According to a 2015 report from the US Department of Education, over 1.2 million students drop out of high school in the United States each year. This staggering number equals to one student dropping out every 26 seconds, or about 7,000 students dropping out of high school every day. So detecting students at risk of dropping out is crucial for preventing these potential outcomes. While various studies have explored the ways to identify the students at risk, there has been less focus on ensuring the fairness in the predicting models used. In our project, we aim to address this gap by examining the fairness of these models, attempt to ensure that all students are given equal opportunities for support or intervention. To keep us at the same page, allow me to explain the concept about algorithmic fairness. We should expect that a predicting model can equally detect the true dropouts on each protected groups, such as the black students versus the white students, the male students versus the female students, after controlling for some factors. However, this is not always the case. Machine learning models might detect one group better than the other. This will implicitly introduce even more disadvantages to the historically underrepresented students. Therefore, we have three research questions. For the first one, we ask, does a machine learning model inevitably introduce bias in this scenario? The second and third one, we ask what the influence will be on the predictive performance or on the fairness when researchers include or exclude the protect attributes. The protect attributes used in our project are about the race, ethnicity, or the gender. The dataset we use is called the High School Longitudinal Study of 2009, which is the nationally representative longitudinal study of more than 21,000 ninth graders. We've open sourced all the clean data and the scripts for this project. Please check the following address if you are interested. For the predictors, based on the past studies and our domain knowledge, we select them from the student level, family level, and school level. All the information were collected at the first semester of all the ninth graders. As for the outcome variables, we use the binary coded variables called X for every job, which is about whether a student ever dropped out of high school. After data cleaning, our processed dataset has over 17,000 observations. We also apply the PMM method to do the data imputation for the missing data. One should notice that this dataset is imbalanced dataset, which may give you misleading conclusions, especially for some metrics for the predicting performance, such as the accuracy. So we use some oversampling strategy called the synthetic minority oversampling techniques. You can stop here to see some details and check the address below if you are interested. When evaluating the predictive performance, we use the following metrics such as the accuracy, recall, specificity, or the AUC. You can stop here to see the details. As shown in the table 2, the machine learning model used in our project are the logistic regression, random forest, XGBoost, support vector machine, and neural networks. As the classification task, we hope our model can have a strong predicting power, which is reflected by the AUC value. In the meantime, we hope our model can detect the true dropouts as much as possible. Based on this criteria, we select the neural networks given its flexibility in parameter tuning. We also choose the logistic regression as our baseline model. As shown in the table 3, after removing the protect attributes such as the race, ethnicity, genders, we found that there are no notable changes among those models, except the logistic regression. Since nearly all those metrics are about proportions, we conduct the proportion z-test about the sensitivity and the accuracy in the logistic regression model and the neural networks to see whether these changes are statistically significant, as shown in the right side, the figure 2. One should notice that the red dashed line on about the significance level of 0.05, the curve under this line is the evidence for the significant changes. So we can find that there is nearly no significant change in the neural networks after or before we remove the protected attributes, but not the logistic regression. Figure 2 can answer our second research questions. Next, let's move to examine the algorithmic fairness on the neural networks and logistic regression model. Zhou and Han 2023 summarized 4 types of the fairness concept. You can stop here to see the details. Please focus on the second one, the conditional statistic disparity. In evaluating the fairness, we use the differential algorithmic functioning depth to detect the fairness. Long story short, the depth is to see whether there is some bias among the 2 different groups after controlling for some fair attributes, such as the SES, the previous academic performance, or the school engagement belongings. You can stop here to check the detail. We used both the depth-MH and the depth-LR method to detect the bias in both the aware NN model and the blind NN model. The up 3 plots are about the MH method, the bottom 3 are about LR method. The results are similar in figure 3. The aware NN model shows no bias in predicting the dropouts in female and male groups from the threshold 0.25 to 0.9. However, it shows significant difference in black and white groups above the threshold of 0.51. After removing the protected attribute from the NN model, the blind NN shows bias in female versus male groups, but the unfairness almost disappears in the black and the white groups. As for the aware logistic regression models, it shows bias for each group across all the thresholds. However, after removing the protected attributes, the unfairness is reduced nearly for all 3 groups. So here comes our conclusions. For our first research questions, does a machine learning model inevitably introduce bias in predicting high school dropouts? Our conclusion is the presence of predictive bias is contingent upon the model used, the protected groups involved, and the specific threshold range. Please stop here to check the following details. As for the second and third research questions, please stop here to check the detail. And in deciding the retention of the protected attribute, our recommendation is that researchers should consider its impact on the 3 key aspects across the range of threshold they are interested in. The first one is the predictive performance according to certain metrics, such as sensitivity, specificity, AUC, etc. The second one is the changes in the algorithmic fairness. And the last one is the practical implication of deploying the model, such as the school principal want to achieve a gender-friendly environment for the students, or the school leader want to achieve the equal opportunity for the student from different race ethnicities. Due to the time limitation of this brief presentation, I intentionally skipped some details. Please check our paper if you are interested in. We are currently working on the extension of this project. Thank you in advance for any questions, comments. Thank you very much.